Hello everyone, and welcome to the 40th episode of Aquatic and Fisheries Science Talks. My name is Mukta Menon, and I'm a scientist at ICAR-Central Marine Fisheries Research Institute, and I'm the host for today's talk. Along with me are Dr. Sajana, scientist at ICAR-CIFRI, Dr. Deepak George, research scientist, Department of Fisheries, Government of NT, Australia, and Dr. Pratish, assistant professor at Texas State University. They will be managing the webinar along with me. So if you have any technical issues, please do let them know. And for all the new attendees today, AFS Talks is an ongoing bi-weekly webinar series inviting speakers around the world to share information and developments in the area of aquatic science in general. Our aim is to link students, professionals, and researchers to open channels of communication, develop collaborations, and develop a skilled workforce for the cause of providing meaningful science to humanity. So this platform is open to everyone and anyone who loves hearing a science talk and who loves giving a science talk. The backbone of AFS Talks is the incredible team of coordinators from various institutions where they circulate our upcoming talks to all potentially interested people. So we welcome any one of you who is interested to be a part of our team. Just shoot us an email at afstalks@gmail.com. And all our upcoming talks are announced in our FB page. And we also have a website, afstalks.org, where you can find the links to all our social media platforms. Now, for the rules for the webinar, please keep your mic turned off. Of course, our webinars are free to attend, but you would need a profile name to be let into the webinar. And we do not issue any certificates. And like I was saying before, please keep your mic turned off. But your webcam is up to you. You can turn it off or on based on your convenience. And if you have a question for the speaker, please do type it into the chat box so that it is visible for everyone. And but you will be given the chance to ask your question orally during the discussion time. So the speaker has 45 minutes and followed by a discussion of 15 minutes. Now, let me introduce the speaker of the day. Dr. Tom C. Joseph is a principal scientist and head of division at the Microbiology, Fermentation, and Biotechnology Division of ICAR-Central Institute of Fisheries Technology, Cochin, India. He completed his bachelor's degree in veterinary sciences from Kerala Agricultural University and master's degree in animal biotechnology from Indian Veterinary Research Institute. He did his PhD in marine sciences from Cochin University of Science and Technology. He has 25 years of research experience in the field of seafood-borne pathogens and molecular microbiology. His current research interests include bacteria of public health significance in seafood and bacteriological and molecular analysis of aquaculture probiotics. He has headed many national and international funded projects, and recently he led an Indo-UK project on prophylactic health products in aquaculture. Dr. Toms will speak to us about probiotics, which offer a promising alternative to chemicals and antibiotics in aquatic animals. Even though probiotics are currently considered safe, there is need for stringent regulations on the production and sale of probiotics used in aquaculture to avoid producing negative results. So, sir, the stage is all yours, please.
Yeah, thank you, Dr. Mukta, for the great introduction. And I also thank all the organizers for inviting me to give this talk. And it's a great moment for me too to present part of my research work of the Indo-UK project, which we did some time back. So the question always, came to my mind was whether the probiotics which is available in the market, the aquaculture probiotics, whether they are really effective or it's overhyped, or whether it has really some effects. So to this question, we just did some work in the Indo-UK project, and then most of my talk will be about the probiotics and also the work, the results of the work which we of the research work we did during that project. So when we think about so when you think about the aquatic foods, it provides micronutrients to around 3.3 billion people and support the livelihood of around 120 million throughout the world. And in India alone, it supports around 1.25 million people. And it is one of the most world's traded commodities. And the global export value of fish is around 164 billion, worth 164 billion US dollars. And half of the total global catch comes from small-scale fisheries. So that itself means how important this sector is to the world. When you consider the aquaculture production, the global fish production is around 179 million tons in 2018, with aquaculture representing 46% of the total production. And this is bound to increase and in years to come, since the capture fisheries is coming down and the aquaculture production is going up. India has a share of 8.6% of the total world production, which with a total production of 7 million tons. And by 2030, aquaculture production will increase by around 42% in India. So in the early 90s, that's when the aquaculture really took off in India. And when we started aquaculture, it was around mostly extensive systems or semi-intensive systems. But later on, when we switched over to intensified aquaculture, the aquatic animals were exposed to high stress situations, resulting in the increase of diseases and thus reducing the productivity. So maybe people will be aware in the early 90s, that was the time when we started encountering diseases that, especially the WSSV. I think it was first reported in 1989, and then on, the WSSV used to be a big problem during culture. So naturally, when the intensification of the aquaculture happened, there was a lot of diseases. So when we really think about diseases, this is one important cycle which we have to always look in, the nitrogen cycle. So what happens is the waste products, along with the uneaten food, it is converted into ammonia, and the ammonia will be converted into nitrite by nitrosomonas, and then nitrite to nitrate by the nitrobacter. So this what happens is when there is a lot of ammonia within the pond, the diseases sets in. So mostly there are pathogens which are inherent to the aquaculture system, just like Vibrios, and also even WSSV. I mean, pathogens like WSSV, it is present in a state wherein it doesn't multiply. But when there is stress conditions, especially when there is increased ammonia levels, or when there is change in the conditions, maybe a reduced DO or the increase in temperature or reduced temperature, that is when these pathogens overtake the immune system of the animals, and that is when the disease sets in. So when the intensified aquaculture started, then we started using a lot of antibiotics. So when we say about antibiotics, I can share you many instances when we go to many of these, say, even hatcheries. When we ask them, they really say that we don't use antibiotics. But then if you really work close with them, even now they ask, they say that they use probiotics. So yesterday I was just talking to one of the hatchery owners. So we were just discussing about one product which can be used for inhibition of Vibrio harvae. And as you know, Vibrio harvae is one of the major issues in hatcheries. And then he was asking me whether this product, it will be inhibited by an antibiotic. So that question itself means that even now antibiotic is being used in many of the culture systems, especially the hatcheries. So when you look into this data, we can see that the RASF notifications, wherein antibiotic residues, when the aquaculture products which has been exported from India, it has been notified by the European Union, and you can see that it has been notified against antibiotic residues, and there have been a lot of rejections, export rejections, due to the presence of antibiotic in many of the aquaculture products. So that is when we really started thinking of alternatives. And the use of antimicrobials in aquaculture is governed by a lot of factors, including legislation and regulation by government agencies. But when you think about regulation, in places like India, where the regulations are very loosely knit, even antibiotics, even though it is banned, it is freely available over the counter, so anybody can go and purchase. So regulations as such may not be maybe a workable solution in places like India. But when you look into the industrialized countries or when developed countries, there are very strict regulations are in place. Also, the pathogens present, I mean, when a pathogen is there, when an infection is there, we tend to use antimicrobials. So there are a lot of factors which influence the use of antibiotics in aquaculture, and including the environmental conditions in the aquaculture systems. So the antimicrobials used in aquaculture varies between maybe very little amounts in Scotland, around 0.39 grams per ton of production in Scotland, to around 660 gram per ton in Chile. So that is the range to which the antibiotics is being used in aquaculture. So one of the problems we face when treating diseases in aquaculture is that even if few shrimps or fishes are infected, we have to treat the entire lot. So we generally add the antibiotics directly into the pond or the hatchery systems. And so that is always a metaphyletic use of antimicrobials. Even if we add in the feed, so it's a treatment wherein the entire lot, the entire batch of fishes or the shrimps are being treated. The entire population is being treated. So as such, aquaculture systems or farms can be considered as genetic reactors of hotspots of AMR genes. So they have a lot of antimicrobial resistant genes present in many of the pathogens or the bacteria which is present. And there is significant genetic exchange which happens within the ponds, and that leads to the transfer of genetic material from a resistant microorganism to a susceptible microorganism. And there are various publications which say that 90% of the bacteria in the seawater, they are resistant to one or more antibiotics. And 20% of the bacteria are resistant to at least 5 antibiotics. So that means a huge lot of the bacteria which is present in the aquaculture systems are resistant to antibiotics. Sometimes what happens is some of the bacteria which are exposed to heavy metals, naturally they become resistant to antibiotics also, because there is cross resistance between bacteria which are resistant to heavy metals and antibiotics. And fish also acts as reservoirs of zoonotic pathogens and bacteria of public health significance. And from there, the bacteria can enter into the human food chain, and then that can cause infection in human beings. So in our lab, we do a lot of study on the bacteria of public health significance, and we have found that most of the pathogens, including the Vibrio cholerae, Salmonella, all these are present in very high numbers in the aquatic systems and also in the seafood. So if these pathogens acquire the antibiotic resistance or antimicrobial resistant genes from the bacteria, then that can lead to resistance of these pathogens also. And what happens is 70 to around 80% of the antibiotics that are administered to the fish or the shrimp are excreted in the water, and they alter the microbial communities present. That is because when these antibiotics are fed into the aquaculture system, the susceptible bacteria, they die, and only the resistance will remain. And then the resistant bacteria will grow, and they overpower all the sensitive bacteria. So there will be a high levels of antimicrobial resistance bacteria in ponds, especially where antibiotic is being used. And this has been proved by many research which has been done across the globe. So this is what happens when this is how the antimicrobial genes are transferred from the closed and open system aquaculture. So here you can see that when the fish is grown either in cages or in aquaculture ponds, naturally in cages, what happens is there is a direct exchange of water between the water in the cages and the outside environment, and from there the antimicrobial resistant bacteria escapes outside. Even in the aquaculture ponds, what happens is when the aquaculture pond water is being, usually what happens is the farmers release the aquaculture, the water after the culture is released into the aquaculture, into the water bodies, and then from there the AMR genes are transferred into the water bodies. So there have been a lot of talk about the deaths which have been attributed to AMR. This is a recent paper which has come in Lancet, which was published in January 20 in 2022, and the paper says that it is estimated that around 4.95 million deaths are associated with bacterial AMR in 2019, and including about 1.27 million deaths, which is attributable to bacterial AMR. So you can just imagine the amount of, the issue that the antimicrobial resistance causes in human beings. So the same is the case even in livestock also, including the aquaculture, even including the fishes and the shrimps. So the AMR, the antimicrobial resistance in bacteria, it causes a lot of issues, and it is going to be a major problem in years to come. So this is something which has been published maybe sometime in 2019, which says that one of the major causes of death in 2015 will be AMR, because of AMR. Because what happens is the disease causing pathogens, they'll be resistant to all the antibiotics which is present, and then that will lead to the infection not getting cured. And it is estimated that in 2050, around 10 million people, that is around 1 crore people, will die just because of the antimicrobial resistance, because they'll die because of infections, because there won't be any sufficient antibiotic which is present to take care of the disease when it comes. So it's going to be a big issue, and that is going to overtake even cancer in terms of the death. So while cancer may contribute to only 8.2 million deaths, the AMR is going to cause around 10 million deaths in 2050. But based on the previous study, which we just discussed, we have found that already we are in line. Almost 5 million people have died in 2019 because of AMR. So this was a paper which has come in Nature Communication, which has seen that you can see that there are some. Yeah. So this was a paper which has come in Nature Communication in 2021 by ICAR et al., which say that there are some AMR hotspots, especially in the freshwater environments in Kerala, Asia. So here, especially we can see in South India, we can see that there are some places which are hotspots of AMR, and even in Turkey and also in China, we can see that there are some few places where AMR hotspots are prevalent. So this clearly indicates that AMR is going to be a problem, and this is mostly in the states of Kerala, Tamil Nadu, and Andhra. But probably this is maybe because there are a lot of publications which come out from these states on AMR. So that may be one of the reasons why the data is maybe skewed, because a lot of data is coming from these regions. But still, it's going to be a big issue in years to come. This is another data from the same paper, which says that even the marine environments in Asia, they are hotspots of antimicrobial resistance. So you can see that these red areas, they are the hotspots, and you can see the Indian coast, they are especially you can see the Gujarat, the Andhra coast, they are AMR hotspots. So there have been unrestricted use of antibiotics for prevention and treatment of aquatic diseases, and that has increased the risk to public health and food safety. And because of the use of these antibiotics, there has been antibiotic resistant, the emergence and the spread of antibiotic resistant bacteria, and also the export rejections, which we already discussed. So there are a lot of linkages, there are a lot of factors which lead to the development of antimicrobial resistance, which is mentioned in this slide. I'm not going to the details of this, but then there are a lot of interlinking factors which contribute to the levels of antimicrobial resistance in aquatic systems. So this picture, all of us are very clear. So there are three factors which contribute to the emergence of diseases. One is the host, the other is the pathogen, and the third is the environment. And the interaction between these causes diseases. So this is where we can intervene. So we can prevent diseases by the use of probiotics, prebiotics, or symbiotics. But we will be mostly dealing about the probiotics today. And also we can use, maybe other than antibiotics, we can use bacteriophages. I mean, our lab is again working on bacteriophages also, even phytobiotics, or even quorum sensing interference we can use for the control of diseases. So mostly we'll be dealing with the probiotics which is being used in aquaculture. So we were studying about the biological control, which includes the bacteriophage, which includes the use of prebiotic, probiotic, symbiotic, or maybe quorum sensing. But why we should use this? Because one of the reasons is the emergence or the re-emergence of several infectious diseases, and then the environmental deterioration that contribute to the infections, the extensive use of antibiotics, which leads to antibiotic-resistant bacteria, and no regulations on the use of antibiotics, especially in the developing countries. So this has led, many of these factors that's led to the use of probiotics in aquaculture. Mostly because the farmers or the aquaculturists were forced to use, especially because there were a lot of rejections, and in terms of export, even though we didn't look into the export, I mean the domestic market, but in the export market there has been a lot of rejections because of the presence of antibiotic residue, and that is one of the major reasons why the aquaculturists went for probiotic usage. And many of the maybe authorities like EMPEDA or the CAA, the Coastal Aquaculture Authority, they encourage the use of probiotics. So there are various factors which has been listed here, which contributed to the use of probiotics. And then the use of these probiotics is very much essential for sustainability in aquaculture, especially the use of probiotics, the prebiotics, the symbiotics, immunostimulants. So there are a lot of things which can be used for sustainability in aquaculture. So always there has been a criticism against aquaculture that the aquaculture as such, the system is not sustainable because of the pollution it causes the environment. So to a large extent, this use of biological control in the control of diseases can help stimulate, I mean, can help towards the goal of sustainability in aquaculture. So there are various mechanisms to control the use of antimicrobials in aquaculture. So one of them is the regulations that do not permit the use of antimicrobials. And the second one is the AIMs, the antimicrobials made inaccessible to the farmers due to the cost or lack of access to pharmaceutical markets. And in some countries, there are only few antibiotics are being approved for use. But in India, as such, none of the antibiotics is being approved for use in aquaculture. Also, there is an option for using vaccines instead of antimicrobials. But one of the problems in use of vaccines is that it doesn't work properly in crustaceans and mollusks because they don't have an adaptive immune system. And designing a cheaper and new vaccines with high efficiency in the future is the key. But even though there have been a lot of efforts in developing vaccines, or even control measures for the control, especially the viruses in shrimp. It's underway, but none of them have been very effective or cheap in terms of the cost. So maybe now in the few slides, coming slides, I will just explain the work which we have done in the project. So what we did is we went to market and we collected around 60 commercial probiotics, which, so as you know, the market of commercial probiotics in India is huge, and very, maybe the estimate says that it's worth around 700 million US, $100 million US dollars. So it's a huge market which is out there, and what we did is we looked for their the load, the microbial load in terms of both qualitative and quantitative methods. So 53 of them were indigenous and the rest were imported. And the predominant microorganisms which were claimed by many of these, maybe the people, the manufacturers were the Bacillus species, the yeast, the nitrifying bacteria, the Thylobacillus, Lactobacillus. So these were the mostly the bacteria which the manufacturers claimed were present in their labels. And the declared benefits include, include the water quality improvement, decomposition of organic waste, inhibition of vibrios, better feed conversion ratio, and survival rates. So some of the probiotics you can see in the probiotics, which the claims has been, maybe it is 10, 15 claims they have made in a single probiotic product. So the thing is, in one of these products, we can see that even the spelling of the meaning of these organisms are wrong. So when we really went to the market, when we interacted with the manufacturers, we found that many of the manufacturers doesn't know, or the people, there is no quality control in place. Many of the manufacturers doesn't know what they're doing. So many of the manufacturers, what they do is they get imported probiotics. If the efficacy is not known, nobody knows what it is, and that it is mixed here. Maybe they add some maybe some fillers, and then it's packed and then it is sold in the market. So that's what we normally see. Now, I don't say that all manufacturers are like that, but we see that majority of the manufacturers, producers of probiotics were like that, and they make very tall claims in terms of the efficacy of these probiotics. So what we did is we categorized these probiotics into different groups. We found that there are 4 different groups. One of the group is the group that is the probiotic. They said about the microbial content and the count. So they exactly said which are all the bacteria which is present and also count which is present. And then there's another group which says only the total microbial count, that is the number of bacteria which is present. And there's one group which says that only microbial composition, that means the bacteria which is present. And there's another group which constitutes around 27%, which doesn't give any details, which just says that it's probiotic bacteria. So you can just imagine how the different manufacturers sell these products in the market. So, and we have found that only 36% of the products with claim on microbial load met the criteria. So that means if they say that 10⁻⁷ or 1 million cells are present, only 37% of the products, that means less than 40% of the products, they meet that criteria. And even though autotrophic bacteria, just like Nitrosomonas, Nitrobacter, they were claimed by around 21% of the products, but none of them they have these Nitrosomonas or Nitrobacter. And we found that 18% or nearly 20% of the probiotics, they have a microbial content of only 10⁻⁴. That means around 10,000 bacterial cells per gram or ml. So that means that is a very little amount. For a probiotic to be effective, it should have at least 1 million, that means 10⁻⁶ to 10⁻⁷ bacteria per gram or ml. But then what we found is that 18–20% of the probiotic products didn't have the bacteria which is necessary for it to make a change. So then also we did a microbial quality analysis. We found that we can see that here, powder 1, it mentioned about the presence of 2 bacteria, and then, yeah, both the bacteria were present. Even though the count was not there, we found that it has very high count, 10 raised to 7, 8 bacteria, both Bacillus subtilis and Pediococcus acidulacti. It was present very high count. But see the second product, it claims to have 5 different bacteria, and actually only 1 bacteria was there, that is Bacillus subtilis, and that too at very low levels, that is around 1,000 bacteria. They claim to have 10 raised to 6, that means a million bacteria, but only 1,000 bacteria were there. And then it really had another bacteria which was not claimed, which is Enterococcus faecium, which is not claimed by the manufacturer. So we can just think that the quality of this probiotic is not up to the mark. So here we have another probiotic product which claimed to have around 10 different bacteria. Then ultimately, when we screened, we found that only 1 bacteria was there at 10 raised to 8 levels. The bacterial count was very high, but then the thing is that whatever is claimed by the manufacturer is not present in the probiotic product. So we also did a next generation sequencing to see whether some other bacteria is there other than the bacteria which has been claimed. And we found that in bacteria in product 1, both the bacteria which has been claimed is there, and there is no other contamination which is present. But you can see that, there was some contamination. You can see that here, these 2 bacteria, they are contaminants. And then in P2, we can see that even though 5 bacteria have been claimed, only 1.67% of the reads. That means very low amounts of Bacillus subtilis was there, while all other bacteria was not present. And the case of P5, again, you can see that very low levels of, out of the 10 different bacteria, only 3 bacteria were present. And when we can see that in this product P4, the levels of bacteria which has been claimed is very less, and the contaminants are very high. So that itself shows that the quality of the products is not up to the mark, and then there is no lot of scope for improvement in the quality of these products. Also, we just checked the presence of antimicrobial resistance in the Bacillus. We selected Bacillus because most of the aquaculture probiotic products, it had Bacillus in them. So we selected around 150 Bacillus isolates from around 15 different products. And we did a MIC assay against the 15 different antibiotics. And these are the results we got. We found that around 96% of the bacterial strains, they were resistant to the penicillin group of antibiotics. And also the macrolides, there was intermediate resistance, around 50% of the bacteria. So that means that the probiotic bacteria which is used in the aquaculture in India, they carry many of these antimicrobial resistant genes. You can say, because we didn't check the antimicrobial resistant genes, but still we can say that antimicrobial resistance was there, so which is not acceptable in terms of the environmental protection. So here we can see that around multi-drug resistance was present in 41% of the total bacteria. That means 41% of the bacteria had resistance to around 3 or more antibiotics. So that also is not a good sign or a good thing to happen in aquaculture. So we also had a doubt that whether these probiotics had some antibiotics in them. So we checked these probiotics for the presence of different antibiotics. So we found that 2 of the probiotics, even though they claim to have bacteria, they didn't have any bacteria in them. They claim to have lactobacillus and yeast, and then we found that only yeast was present. And then we did an LCMS analysis. We found that 4 different chemicals were there, 3 different bacteria, and when we had an antiparasite, a parasite which is albendazole was there. So we had ciprofloxacin, we had trimethoprim, and sulfamethoxazole in these 2 probiotics. So what we found is that in India, when we take, the government regulation says that, even though recently some regulations have come where they say that the contents of the probiotic should be mentioned on the label, but till now, what has happened is the government regulation only says that the probiotic should be free from antibiotic, and which has to be certified by the Coastal Aquaculture Authority. And we found that around 1,429 feed additives, 830 probiotics, and 92 immunostimulants have been governed by permission by CA to sell in the Indian market. And then when we really see, there is no proper criteria for assigning. So if the manufacturer is claiming that it's a probiotic, it's a probiotic. If the manufacturer is claiming that it's a feed additive, then it's a feed additive. So there is no proper proper criteria to assign a particular aquaculture input into a different category. And so from the study which we had, we could find that the actual quality and the safety of the commercial aquaculture probiotic sold in India is definitely under question. So we have few recommendations. One of the recommendations is there should be measures to prevent the development and spread of antimicrobial resistance in aquaculture. And there should be strict regulation in place to prevent the occurrence of antimicrobial residues in aquaculture products. And studies to assist the plants in aquaculture and the natural environment should be initiated, and the capacity to monitor the in aquaculture should be developed, and there should be harmonization of the methods to monitor the prevalence of resistant bacteria, and also the antimicrobial residues should be in place in the country, so that the probiotics which we use is safe for both aquaculture and for the humankind. And I would like to thank the Newton Fund for giving us the funding for conducting this study. And also I would like to thank the organizers for giving me an opportunity for presenting this work. Thank you. Thank you so much.
Thank you, sir. That was a lot of new information for me personally, actually, and very interesting talk. Thank you so much. And before we move on to the discussion, I will just, I've just pasted a link into the chat box for feedback on today's talks, as well as if anyone feels they would like to listen to certain topics or particular speaker, please let us know. So there are a couple of questions in the chat box, sir. So I'll just read them out or ask the people who've typed them in to actually unmute themselves and ask. Gokul Shanmugam, is he here?
Yes, ma'am.
Please, can you go ahead and ask your question?
Yes, sir, in biofeed, other than nitromonas and nitrobacter, some probiotics are using only this nitromonas and nitrobacter. Hello.
I'll just read out his question actually.
Yeah.
What he had asked was,
Hello?
in the nitrogen cycle, any other bacteria or probiotic used in the biofilter other than nitrosomonas and nitrobacter?
Yeah, recently there have been a lot of studies which says that even heterotrophic bacteria, they are involved in the nitrogen cycle, and they convert these ammonia into nitrite and nitrite. So there have been a lot of papers recently, off late. Even Bacillus is there. So there are a lot of other bacterial strains or bacterial genus which is involved in the nitrogen cycle, which are heterotrophic. So did I answer your question?
Yes, sir.
Thank you, Gokul, for the question. Madhu sir has a couple of questions. Madhu sir, will you unmute and ask?
Yeah, thank you, Mukta. Tom, it was a fantastic talk. My questions, I have a couple of questions. One is, as you said, that AMR transmission potential of probiotic bacteria is there. So do you think that the benefits of probiotic bacteria far outweigh the transmission potential?
I think the major issue there is that actually we don't have a proper regulation in terms of the use of probiotic strains. So once a regulation is in place, or when we are able to maybe characterize a strain and maybe make sure that these strains are free from like AMR's genes, then definitely that can be very well used as without any issue in aquaculture. So the major issue there is the presence of AMR genes. So if the manufacturers are aware of the potential of transfer of these AMR genes into the maybe the aquatic environment, or even in the human pathogens, or even the animal pathogens, I think that can take care the issue of AMR transmission to a large extent. Did I answer you?
Yeah, you very well answered. I have one more question. That is, most of these probiotics are multi-species formulations. When we apply them in the aquatic pond, do you think that one of the strain may predominate or grow in a faster rate than the other things listed in the probiotic formulation? One is, as you have seen, the composition is different. Second thing, even though the composition is same, all the bacteria are there, one of these strains may grow faster and express its effect, whereas we don't get the effect of other species in a multi-species formulation. What do you think?
Yeah, definitely. I mean, maybe there will be some species which may be growing faster than the other. Even we have seen is that when even in probiotic manufacturing units, what happens is the multi-species probiotic formulations, they put all the bacteria together in the media and they try to grow it. So even there, I think one species always dominates, because the nutritional requirements of many of these bacteria are different, and there is always chance that one strain predominates. The same is the case in aquaculture ponds, because I feel they add more than one strain, because maybe different strains will have different growth requirements, maybe different pH requirements, different nutritional requirements. So the multi-species probiotic formulations are formulated so that at least one of these strains will act and they give the effect.
Thank you.
Yeah, definitely. One strain or one or more strains will dominate if there are 10 probiotic bacteria. But what we are seeing is that even though the manufacturers claim to have around 9 to 10 strains, but then only one strain is really there. So there is no even the question of like one strain dominating in the aquaculture system doesn't exist there, because only one strain is there. So only that strain is there. Only that strain will be predominating. But otherwise, there is always chance that one strain can predominate. One or maybe few of the strains can predominate. Yeah.
Thank you. Thanks for the clarification, Thomas. Thank you, Mukta.
Thank you, Madhu, sir, for the
Thanks, Madhu.
And Dr. Rajshekharan has a comment actually that it is quite pathetic to know that the commercial probiotics are not genuine and not having the, so-called the declared bacteria in them. Then the next question is from Alashore Marine Exports. Is there any specific difference between veterinary drugs and aquaculture drugs?
No, as such, I think veterinary drugs and aquaculture drugs are same. I mean, only thing is the formulation matters. Even veterinary drugs are used in aquaculture. That's what I understand. I think Dr. Madhu can throw more light into it. Madhu?
Yeah, there is no specific thing as an aquaculture drug, because till now there is no drug specifically manufactured for aquaculture. It is a human drug which has come into terrestrial animals. The same drug has moved to the aquatic animals. But in aquatic animals, there is a difference because we have fresh water, brackish water, marine water. So the same tetracycline, if you put in fresh water, it may work. But in marine waters, it will bind to the calcium and magnesium and it will not work. So there are a lot of intricacies in the aquaculture system. So as of now, as Tom has already put this in his slide, the drugs approved for aquaculture in US and Canada, they are under the category of aquaculture drug. That is, which have been permitted for use in aquaculture. It is basically a drug from veterinary science, but it has been permitted to use in aquaculture. So specifically aquaculture, there are no drugs, but what I feel is fluorphenicol. There is one fluorphenicol derivative which has been specifically prepared for aquaculture. Otherwise, veterinary drugs and aquaculture drugs both are synonymous.
Thank you, sir. Thank you. The next question is...
I think your question is answered.
Yeah, I'll assure marine exports, I hope both the sirs have answered your question. The next is actually a comment, a question, Shivaraman, intrinsic resistance to these antibiotics. I didn't understand. If Shivaraman is here.
Yeah, I got it. Yeah,
okay.
Maybe some of the resistance what we got is intrinsic resistance. Definitely, there is every chance. Maybe some of the strains are intrinsically resistant. But the thing is that the point here, what I want to raise is that the manufacturers are not aware of the presence of AMR, antimicrobial resistance, in any of these strains. So really, the regulatory agencies and the manufacturers should put their heads together to see that which all, even if it is an intrinsic resistance, which all are allowed and which are not allowed in a particular strain or species. So that should be there from the regulatory point of view. So that was the point which I tried to put across.
Yeah, it's correct, sir. But maybe it told us some of the antibiotic like ampicillin, they are instinctively resistant.
No, what we found is that they carry the it's not only intrinsic resistance, they carry the enzymes, which is because we did an enzyme assay also, they carry the enzymes which is required for resistance. So it's not intrinsic resistance alone. They did carry the enzymes.
Okay, Shivaraman, hope that answers your question.
Yes.
Thank you. And next question, sir, is by Naveen Kumar. He says it's a very informative talk, sir. What is your recommendation idea for doing future research in effective probiotics and plant-based immunostimulants? It's for he's a research scholar. Then how to extend the shelf life of probiotic products?
Yeah. Regarding the future research, but as such, I think probiotic research it's in its infancy. Even if you take human probiotics, they are still in the infancy. There are a lot of papers which comes in human probiotic. Now they say microbiome is the future drug. There are a lot of papers which are coming in which says that maybe in certain conditions, even in cancer, even in maybe cecal cancer or whatever cancer, or even in case of some of the diseases, most of the diseases, it's linked to some sort of microbiome. So in future, even in humans, it's planned that we should have designed probiotics wherein we say that for a particular disease, this is the probiotic formulation which we have to take. I think the aquaculture has not gone to that extent, but there are different papers which says that there are certain criteria which is set for the presence of certain criteria which is for selecting a particular probiotic. Like it should be acid resistant, it should be bile resistant, it should be maybe it should be inhibiting the pathogens. So there are various criteria which is laid. So if these criteria are strictly followed along with the absence of antimicrobial resistance, I think that is the first thing we should be focusing before we go into any future research in the use of probiotics. Regarding plant-based immunostimulants, definitely, what we can do is we have to find out the toxicity of these plant nutrients and also find its effectiveness in terms of stimulating the immune system or in terms of suppressing a pathogen. So that's how normally it is done. There are a lot of papers which is available, which helps us to select a plant as an immunostimulant. So mostly it is based on how well it can stimulate the immune system in fishes or shrimps. And then regarding your third question, how to extend the shelf life of probiotics, as far as Bacillus is concerned, Bacillus is a spore former, so there is no need of any sort of need for extending the shelf life because it is present in spore form, so it doesn't die there. But then for others, it's difficult because some of the maybe probiotic bacteria like maybe like lactobacillus, they have to be maybe we have to use different methods to lyophilization to preserve them. So other than that, we have to maybe try our own to see how we can extend the shelf life. Because what happens is normally when you go to the aquaculture farms, we find that these probiotics are stored in Andhra and all, the temperature goes up to 45, and then most of these probiotics are stored in maybe enclosures which is made of metal, and the temperatures inside will be around 50 plus, and then most of the bacteria will die in those conditions when the temperatures go very high. So I think we have to do various trials and experiments to see how to extend the shelf life. So regarding Bacillus, that's why Bacillus is one of the most commonly used probiotic strain which is used in aquaculture. That is mostly because of it is able to survive under varying conditions in terms of temperature as well as pH also. Yeah.
I hope that answered your question.
Thank you, sir. Thank you, sir.
Our next question is from Pavan Kumar. In large fish farming like 50 to 100 acres, diseases are not cured by probiotics, so then antibiotics are used in large amount. So is there an alternate for antibiotics other than probiotics?
No, as I was telling, there are a lot of, first thing is, as we have seen, the quality of many of these probiotics are not good enough. So that may be one of the reasons why it's not acting. So you have to choose an antibiotic. I don't say that all the probiotics are bad, but we have found that many of the probiotics are really good, but I don't want to say the names here because I don't want to promote any of these because it's not good on my part to promote any of these products. But otherwise, there are certain products which are really good. Around 20% of the products are really good. So maybe the products which you have used, maybe or you might have experienced is that they are not good. So that's why it is not effective. But otherwise, there are other strategies like the use of symbiotics, the use of prebiotics, the use of maybe phages. So there are a lot of strategies which are coming, and many of them are in the developmental stages, but there are many of them which are in use in the aquaculture system.
I hope, Pavan, that answered your question. So
I hope I answered.
Yeah, people are not responding, so I'm hoping that they are satisfied. Then the next question is from Anil Rana. How do farmers select a probiotic for their biofloc ponds?
You can't just the same answer which the previous answer stands good here also, because we can't recommend anything good or bad. It's based on your experience, and it's based on normally what I've seen is that reputed companies, they produce good probiotic. So always go by probiotics which are produced by reputed companies. So they normally work good. And then maybe what probably you can do is that you can check this probiotic for the presence of the bacteria, first of all, and also whatever is claimed, whether it is there. So that can be checked in a microbiology lab, and then you can just use them. So you can't specifically say, because normally water probiotics has to be used in a maybe in a biofloc pond, and then any probiotic will be good if it works well. So you can't suggest which is a good probiotic to be used in a biofloc pond.
So Anil, I won't ask you next question, which is, he wanted to know a good brand. So we will not ask that question here.
All right. Ma'am, can I have a follow-up question?
Yeah, please. Can you speak slightly louder?
Can I have a follow-up question?
Oh, please.
Yeah, please.
So my question is, being a farmer, I'm based in Himachal Pradesh. Though we do not have, much of this, but under the Pradhan Mantri Matsya Sampada Yojana, we've gone in for an earthen pond, with pond liner, and we want to do biofloc. Now, your study really, put me in concern. How do I know? Because being a farmer, I can't send the probiotic first to a testing lab and then go for it. In biofloc, it is the culture of bacteria that we have to do. If we put the wrong thing in, everything goes for a toss. And as a farmer, all that investment and everything that you planned will go for a fix. So, no doubt, they, as you rightly said, that there should be rules and regulations to monitor the probiotics. But still, how, from a farmer's point of view, how should I select a probiotic? Again, I'm coming to the same question, so that I don't end up losing all that investment that I have made just because I was following the right steps, but the only step that went wrong was that the probiotic was not right. They'll change whole of the equation, and the farmer is going to lose a lot of money on it. What is your take on that?
Yeah, Dr. Mukta, can you just make it short and tell me?
Yeah, basically from the he's
Yes.
just his concern that investing so much as a farmer into an enterprise, and then just because he could not get the suitable or the best performing or good performing probiotic, he ends up with a loss. So how to go about selecting a good probiotic? So
Yeah, that's a very difficult question. Probably what we can do is maybe you can, whichever you want to use, maybe send it across to our lab. Maybe we can check and tell you, whether whatever they have claimed is there or not. So that much we can say. But then the activity of these, because many of them they claim it has antipathogenic activity. It can remove ammonia. So many tall claims will be there, and that require a lot of time to study, because this has to come from the manufacturer itself. It should not be from. It should not be from the consumer who should be checking all this, but actually the manufacturer should check all these and then they should release into the market. It's not the other way around. So as of now, we don't have anything, any strategy in place to check whether these are effective. But maybe personally, if you can just email me, I can suggest you few probiotics which can be used, which we found in our study to be good. But then I don't don't quote me anywhere, because I don't want to put myself in difficulty. And but this is what we have seen in our study, that few of the probiotics are really good in terms. But we have checked in terms of only, we are not checked in terms of its activity, but we are checked in terms of the presence of the strains which are they already mentioned in their maybe their cover, and also the quantity and the quality of this probiotics. So probiotic strains. So that much we can say. But beyond that, whether it's effective or not, it requires a lot of study into that. But what us a researcher or as a regulatory agency, what they should do is that we should ensure that the probiotic strains which they are used, the claims made for each strain should be commensurate with what we are supposed to get. So, and the conditions for getting these effects. So that has to be well laid, and then only we can ensure that a probiotic will be effective. Hope I answered.
Anilji, hope sir answered your question, and maybe you could put in an email to sir.
Yes, sir. Yes, sir. Yes, sir. I'll do that, and thank you very much for this.
Okay, welcome.
So as a follow-up on that, I have a question. So based on your research, can you maybe suggest for blacklisting certain brands which actually claim something and actually don't have anything in it? Is that possible?
But then the regulatory agency has to take the decision.
Yes.
And then they have to maybe they have to ask some agency to do that. I mean, before it is being, because we can't just ban some chemicals based on, because there is no regulation in place. So
Right.
unless we put a regulation in place, we can't say that this is not a probiotic, this is a probiotic. So that has to be in place first, and then it should be followed up with other things. So the thing is that we have to develop maybe laboratory facilities wherein they can be checked. A third-party laboratory where it can be this effect of this probiotic can be checked, so that these probiotics are approved for marketing in aquaculture settings.
Thank you. Then we have a question from Tausif Ahmad on efficacy of bacteriophages. How effective are they in aquaculture systems?
Can you say it again?
Bacteriophage efficacy.
Bacteriophage. Yeah, bacteriophage. The thing is that normally most of the bacteriophages are highly, they are highly specific. So they can be used only for against a specific group of bacteria. And for each bacteria, you should have a separate probiotic. So that is one of the issues you face when you use bacteriophage in aquaculture system. So definitely they are very effective. They can reduce the load of pathogens. May not be completely eliminate the pathogens, but then to a certain extent they reduce the load. I think there are some even in human therapy they are being used. Bacteriophage is being used in Russia. They are being used. So definitely in aquaculture it can be used, but I'm not aware whether there is any product which is available for aquaculture system.
So I hope that answers your question, Tasif. And
yeah, thank you, sir. Thank you.
Thank you. And yeah, so Das Gupta ji is saying that we do need a policy for use of such products based on research findings. And again, our farmer friend Akhil Rana has said that they will write to the government to actually ban probiotics. So Swami Fisheries is raising their hands if they have a question. Or anyone else, if anyone has a question, please go ahead.
Swami Fisheries. Okay, if Swami Fisheries does not have a question, I have some follow-up question for you. Excellent presentation, excellent information, and excellent work. I really like it. One of the issues that you talk about is the so in one of the slides you showed the geographical distribution and the antibiotic resistance. You already showed in the different part of the country, right? Is it my first question is it we are late in managing all those things, and in terms of the geography, you already show that the extent of antibiotics resistance is higher in certain region, and even if we manage now, how far we can get rid of that resistance, or right now the farmers like Mr. Anil was asking, we are investing and we need some kind of chemicals to control our farm in order to protect the investment, right? So since already there is a antibiotic resistance in place in most of the country, even if we come up with a management policy or regulation, will that be effective? That's my first question.
Yeah, shall I answer that?
Yes, please.
Yeah, the thing is, your question was like already the AMR is there, so whether any strategy would be effective for maybe the damage is already done, so whether any strategy will be effective to maybe bring it back to the previous stage, right?
Yes. Yes.
Yeah. The thing is that when there is an antibiotic pressure, that's when the antimicrobial resistance develops. So when the pressure is released, the antibiotic pressure is released. That means when there is absence of antibiotic, what happens is that many of these antibiotics are coated by plasmids, and normally they shed these plasmids because it no longer requires these plasmids, and they shed these plasmids and they come to the native state. And also that sometimes what happens is when the antibiotic pressure is there, only antibiotic resistant bacteria can grow. But when the pressure is released, what happens is other native flora also will grow along with that. It's just like imagine a deforestation followed by afforestation. So what happens is when all the trees are cut and then there is a barren land, then slowly one tree is put, then slowly spreads. So that way, I think we can manage. I think it's not completely a very bad situation. We can always bring back to may not be completely come back to what was there. But the basic thing is that, even when you see, even in Europe, in mummies, the mummies which are stored in Egypt, they had antibiotic resistant bacteria. So antibiotic resistant bacteria is not a new thing. It was prevalent from time immemorial. But only thing is that because of the use of antibiotics, there has been selection. Because of anthropogenic activities, there has been selection against many of these antibiotics, and antimicrobial resistance has evolved. And that can be reversed to a certain extent by reducing the use of antibiotics in the system. So one of the things we should always remember is that aquatic system is one of the major, and even when policies are made, the aquatic systems, even aquaculture systems, are totally neglected in terms when you make policies with regard to AMR. But the thing which we should understand is that AMR spreads faster in an aquatic system because that is a three-dimensional system, unlike maybe in a terrestrial animal or human beings. This is a three-dimensional system, and this water, once it is released, it can go anywhere, and then that can spread very fast. So even when the governments make policies, especially in India, I don't know about other countries, what we see is that the aquatic environments are totally neglected, and more focus is given to human side and the veterinary side. But the thing we should understand is that we should be focusing more on the aquaculture side, and we should take this a holistic approach, a One Health approach, rather than maybe focusing on one aspect or the other aspect. So it should be a One Health approach in terms of when you look into AMR as a whole.
Okay, thank you. Thank you. That was an excellent way of doing it. I have another question regarding this is something I don't want you to put in a hot spot or something, but you said that one of the authority that right now looking at these kinds of regulations are coastal. You said some organization, right?
Coastal aquaculture authority. Yeah.
Yes. So is that looking at from a policy or a regulation point of view, most of the time, like in India might be having some regulation, it might be the lack of execution is the problem. So did you, whenever you did the study, did you take a look at is there regulation in place, or is regulation is not at all in place for aquaculture? Or if it is not, is it the lack of execution making the problem?
Yeah, see, initially there was no regulation in place. Before 2019, it says that the probiotics which is marketed in India should be free of antibiotics. So that is the only regulation that is available. Now, recent regulation, it says that in their maybe brochure or in their packet, it should be mentioned which are all the bacteria which is present, and that should be clear. That count also should be mentioned. That is there. But the thing is, I mean, who will ensure this? I mean, that is not mentioned anywhere. So they whatever antibiotic, bacteria you are putting in this probiotic should be mentioned, and also the count should be mentioned. But nowhere it is there that who will be ensuring this. So that is rightly pointed by you. Execution of any regulation is a big issue in countries like India, and I mean, we don't know how it can be overcome. Yeah, it's a difficult question because it is inbuilt in the system. So
yeah, thank you. This is something like, you know, I was thinking whether, I don't know whether it is right, but farmers also can have. So you said that, you know, the manufacturers are need to be doing some of these things to make sure that, you know, they are coming up with a correct product. I think if we are educating the farmers about the importance of these probiotics, and then if the farmers are pushing or excusing the manufacturers, hey, I am not going to take this product if you're coming in with the wrong one, then I think even like in countries like in India, where execution of you know, those regulations are not being followed correctly, the push from the market itself can excuse the farm manufacturers to come up with a better product. So maybe through the extension activities from our different, you know, research institute, we could give them training on like what is the use. I mean, I know some of the farmers are like, you know, not educated. They don't know the importance of probiotics, and they don't know. So they are looking for the cheap products, and they will go for the cheap products. And, you know, most of these manufacturers are ready to give them for cheap because, you know, it's anyway, it's profitable for them, right? So through excusing through the market can also be a good strategy. That's what I think. I don't know. Maybe you can elaborate on that.
Yeah, definitely farmers should be educated always. But how it works is that normally the farmers, they send their samples, maybe water samples or the shrimp samples for testing. Maybe they look for different parameters. Maybe the Vibrio count. Normally they check for Vibrio count, they check for pH, they check for alkalinity. So different parameters they will check, and then this is taken to a person called aquaculture consultant, and then he is the person who prescribes this probiotic to the farmers. So as such, the farmers doesn't have a role in selecting these probiotics. So that is where the problem lies. So whichever product the aquaculture consultant feels is good, then that is prescribed. And mostly the farmers are unaware of the quality issues in these probiotics, because probiotic is comparatively a newer concept, and then most of the people doesn't know what is in them. They just know that it's probiotic. So other than that, much more than. So as you rightly said, I think there is a need for a lot of extension activities to make the farmers aware what is exactly a probiotic and how to choose a good probiotic, and how we can make sure that whatever is being used is the right one, or maybe it is effective. So all these has to be maybe they should be made aware of it, so that at least they will question the aquaculture consultant when they prescribe this probiotics.
Yes. Yeah. Thank you so much.
Thank you, Pratish. Sir, there are quite a lot of people who want to know about brands. So shall I suggest that they write to you on your email ID?
Yeah.
Okay. So anyone who wants to know about the good brands, please write to Sir. Sir has already shared his email ID here. And one final question or comment.
But the disclaimer is that I don't mean, I don't take any, what is that? I mean, if something happens, then I don't take, I mean, it's based on our study. We have found that these probiotics are good, but that doesn't mean that I recommend that for use. So it's very clear.
So with that disclaimer, please do write to sir. So just one last observation from Dr. Rao, that most of the rivers are flowing from north to south. So is that the main reason for AMR presence seen more in the south of India?
So what I feel is that most of the research institutions which is related to aquatic systems are in the south. So that may be one of the reasons why the number of papers are more in the south, because I have not analyzed, because that is based on, I mean, they have collected papers from 2000 to 2019 and they have analyzed it. So, and then they have found the findings. So it's not a research actually, it is just they have collected all the papers which is available from 2000, that has been published from 2000 to 2019, and they have made it into a paper. And maybe probably I feel the reason is that there's a lot of work on AMR in the south. So that may be the reason why the presence of AMR has been detected more in the south of India. I may be wrong also, but then this is my feel.
Thank you, sir. So I think I will stop for the day. That was a very, very interesting talk, sir. And for me, I had a lot of new information coming in. Thank you. And before we leave and stop for the day, if anyone is interested to be a volunteer with AFS Talks, please do send us an email. And wishing you all a very good night. Thank you, sir, once again for sharing your research with us. Thank you.
Thank you so much. Thank you so much, Dr. Mukta, for inviting me, and also, and thank you all the participants for actively participating in the discussion. So when the participants actively participate, that's when the speakers will be happy, because that's when they understand that, yeah, it has reached the participants.
Exactly.
Yeah, thank you so much, and have a great night.
Thank you, sir. Bye, all of you. Bye.